For this one, we're working with factorials and the fundamental counting principle. So the first one is going through and simplifying by hand the 8 factorial over 6 factorial times 2 factorial. So that exclamation point, like I already said, is what is called a factorial. So what that really means is that you're multiplying that number all the way down to 1. And many of your calculators, if not all of the scientific calculators, should have some sort of factorial button on it. Depending on what type you have, once again, depends on where that's going to be located at. So make sure that you're checking that you know how to run that on your calculator, because especially if you're working with values that have large numbers, you're not going to want to multiply all the way down to 1 each time, especially whenever you're doing your permutations and combinations. So the 6 is also 6 down to 1, and then 2 is also 2 times 1. So each of those, you're then multiplying together that 6 factorial, so all those values down to 1, times the 2 times 1 at the end there. And then just like whenever you're simplifying with any type of number, here we can cancel out the 6, the 5, 4, 3, 2, and 1 with the like factors in the top and the bottom. So just like whenever you're simplifying fractions before, if you have some factor in common, you can cancel those out with each other. So here, this will simplify down to 56 over 2, or in other words, 56 divided by 2. So then our final answer here is 28. So that's how you would go through and simplify that by hand. Of course, if you're checking this with your calculator, you would want to make sure to put parentheses around that denominator if you were going to try and enter that into your calculator all at once. Because otherwise you will get a different answer. Your calculator will automatically do the numerator divided by the denominator and then multiply that last answer instead of having the 6 factorial and the 2 factorial both in the denominator. So make sure you're careful of that as well. For number 2, find the number of distinguishable arrangements of the letters in the word members. So the key thing here, first of all, is count to see how many letters you have all together in whatever word you're trying to arrange the letters of. So in this case, we have 7 letters, so we'd have a 7 factorial in the numerator in the top there. And then you want to count to see how many of each letter you have. So for instance here for the M, there are 2 M's, so we'll have a 2 factorial for that, times, and then the E, looks like we have 2 of those as well, so we'll have a 2 factorial there. And then if you look at each of the other ones here, so for instance the B, there's only 1 of those. And then the R, there's 1 of those. And then the S, there's only 1 of those. So each of those would be as a 1 factorial. But keep in mind that a 1 factorial is just equal to 1. So if you multiply anything by 1, you don't really have to have these here. The reason I normally put them in there is so that way you can double count to make sure you had all your letters accounted for, that you didn't miss something. So for instance, if there were 3 M's instead of 2 M's, you might be able to catch that if you're going through and writing out all of your values here. But then once again, separate the top and the bottom. So here for the 7 factorial there, you should get 5,040. And remember that's the same thing as doing 7 times 6 times 5 times 4 all the way down to 1. Or using your calculator to do the 7 factorial. And then in the denominator, you should get 4 whenever you multiply those together. Because 2 times 1 gives you 2, times another 2 gives you 4. But make sure to be careful, because if you were, for instance, to have a 3 factorial instead, 3 factorial would give you 6. So just because in this case it happened to be the 2 times 2, doesn't mean that will always be the case. If your factorials are bigger numbers, they're going to be bigger values than that. So make sure to be careful if you're trying to do any shortcuts there, that may or may not work depending on what numbers you have. And then the last step, once again, is to go through and divide. So your final answer there should be 1,260. And then for number 3, we have assuming that all of your clothes match each other. How many outfit choices do you have if you have 7 shirts, 5 pants, and 2 pairs of shoes? So this one is using that fundamental counting principle. So all that is you multiply together the number of shirts you have times the number of pants times the number of shoes to see how many outfit combinations you have, assuming that they would all match each other. So even just having that small selection there, you would have a total of 70 different outfit choices you could have, assuming that all of those matched. So make sure if you do have questions on any of that stuff, make sure to ask like normal.